Sup guys, welcome to today's show. So, is it possible to count function arguments in C? Let's say I have a function which I'm calling like this. So, something like this. So this I want to return 3. And if we have a fourth argument, I want it to return 4. How do we do that? We cannot do it with functions, that's for sure. But perhaps we can do it with macros if we manage to make them recursive. Let's try. How do we do this? Let's make it easy. Let's say that we have a null terminating function for now. So if x is 0, in that case we want to return the arguments. No, let's see, we want to return the number of arguments. Otherwise, we want to return count with the current number of arguments plus 1. And then the rest of the arguments. So we peel off one argument at a time because we return x's. We do not return the first argument and the rest. So this could actually work. So how would we initialize such a thing? We could do something like, if we call this count with an underscore first, and then we define the regular count, which only takes args, so x's, and this will return underscore count and start the recursion by providing a 0 as the number, starting number, and then providing the arguments like this. So let's, just to have something, let's say we have, let's create an integer data type. So we say we have an unsigned char, which we call int 8. And our int 8, so let's say we have an int 8 number of args, which is equal to count, and then we have this a, b, c, like this. Let's see what the preprocessor makes out of this. First, does it even compile? Oh. What happens if we run, let's see. If we run CPP, that's the C preprocessor. So it translates this. So if A is 0, we return 0. Otherwise, count of 0 plus 1, B and C. So this part seemed to work. But the preprocessor doesn't really like that we define this recursive. What if we were to first define this as something else? So let's say A, B, C, and let's return 0 or something. This should compile, I think, because this should be the same, right? We get a warning that it's redefined, but does it compile? Count has the same problem. No? Implicit declaration of count. Why is that an implicit declaration? Because we do define it up here. Count 0. Maybe because of the wrong number of arguments, is that it? This, however, does make sense. It's not a constant, so let's move this into here instead. Still get an error here though. What if we were to do something like this? So we define it with 2 arguments. Wait. Let's define it like this. And maybe just like this. Why is it an implicit declaration? It does exist. And the preprocessor itself makes the right thing out of it. Is it possible to bypass that error thing? Could we simply remove this check? What if we have a similar function but with a different name? So let's say we have Then we have the same problem here instead. So we define this with this. And this with this. It's weird that it complains on the underscore count, but not on the double underscore. I guess it's because this is the first location. How can we go around this? Could we bounce by creating a function? Maybe. So how would that look? Something like int 8 count ... maybe. All right, let's see what happens. Macro count requires 3 arguments, but only one given. That's right, this needs to be above. Okay, it compiled, that's interesting. Let's see what the preprocessor says. I guess this is going to call this function. Let's see. If A is 0, return 0. Otherwise, if B is 0, return 0 plus 1, and then count. 0 plus 1 plus 1. So the idea works, but we would probably need to have as many levels as there might be arguments. Let's just try to add one more level. So this will be count with 3 right here, calling the one with 2, the 2 calling the one with 1. Or am I going the wrong direction here? I think I am. So count calls underscore count. Underscore count goes to double underscore. Double underscore goes to 3. And 3 would go to 4. And let's make that the function. Did I miss something? expected expression. Isn't this basically what we did before? Why would it give an error like that? So count refers to this underscore count. Which refers to this. One, two, three, four. 1, 2, 3, 4. One, two, three, four. Let's call this one f count instead, the function count. What does the C preprocessor say? A is 0, then 0. Otherwise, if B is 0, then 0 plus 1. And if C is 0, we have 0 plus 1 plus 1. Zero, then 0 plus 1 plus 1. So here's this and this. Otherwise, we have f count of 0 plus 1 plus 1 plus... Oh, it's the argument. Because there's no argument left. What if we were to just do this? What would happen then? Still the same problem. So how do we deal with that? So this is why I wanted to create my own C preprocessor, because it's so very limited, the abilities in C. Because access is nothing at this point. Maybe we need to do this. Yeah, we do. I forgot about the null terminator. So that's right. So we need to add that everywhere, perhaps. But that won't really help, will it? Maybe. Let's try. Yeah. Might actually work. Let's try to print that thing. So something like this. 2. Pretty nice. And what if we were to add the C here? Then it goes to 0. But if we have just 1, then it goes to 1. Okay, so we need to have one more of these underscore macros than we need, then we have arguments. So if we were to continue this, we would, after a while, have something that actually works. It doesn't make the cleanest looking code, but the general idea works. And why do we need something like this? Well, if we are able to do this kind of recursion, there should be possible to create like a generic console.log function, similar to JavaScript. So we don't have to deal with printf and format strings and kinds of variables. We could just say print and whatever. So maybe that will be the next step. What do you think? Could we do something other with this? And besides, do you have a cleaner solution to this? Please let me know. I really hope you liked this episode. Don't forget to like and subscribe. And thank you for watching. Thanks for today.